Okay, so now it's time for the dreaded lab broker, because that's where we have access to FTK. Hopefully you all have gotten this far. I mean, I think everyone's used this, right? If you haven't, it took me a little bit to figure it out. The passwords and stuff were discussed earlier this semester, and they're up on. It was in the student cafe or the Ask Your Professor, one or the other. Someone had posted that information. So if you're not getting on this successfully, please let me know, because obviously if you're not getting on this, then you know you're going to be having a lot of trouble. So what we want to do is we want to use FTK to look at the disk and look for these different executables. The one we know of for sure is tango.exe that was suspicious. The svc host.exe that was suspicious, we're not quite sure what's up with that, right? Like, I mean, it's just svc host.exe, right? So it's probably the legitimate executable of svc host.exe. We don't really know yet at this point. Man, this lab broker is just like, sometimes it's so kind of like pokey. And you can't tell for sure, like, did I double click on that? Is it starting up? There we go. So FTK, I got to warn you, I have not, until this semester, I have not used FTK in a very long time. I use Ncase Fairmount. I use a program called Xways even more. It's kind of the other, those three programs. Ncase is probably the most widely used forensic suite. FTK is probably second. Xways probably third. There's a couple of others out there that people do use. One's called Magnet Forensics. And then another one that I really recommend people consider learning is what's called the SIFT Toolkit. And it is this is another one we use actually at work, and it is a completely open source, you can download the entire thing as a VM from SANS. It's maintained by, it's not maintained by Lenny Zeltzer, it's one of the other forensics guys. Maybe it's, what's the guy's name? It's Rob Lee, yeah. So it's Rob Lee at, so the username and password, if you haven't done it yet, if you haven't done any FTK yet at all this semester, in which case, if you haven't even logged into it, then I'm not sure what you've been doing. So you have to create a case. I already created a case for Lab 4, but if you haven't, what you want to do is you would just say you want to create a new case, you give it a name, and basically you just hit OK. There's not a whole lot to it. You can just leave it as forensic processing. All the rest of this stuff doesn't really matter all that much. You can give a description if you want, reference if you want. All that stuff doesn't really matter. So you create a case. Once you create a case, so I'm opening up my existing case that I have for Lab 4. And here it is. Once you have a case open, you can add evidence. And I've already added our lab file, but if you haven't already done that, then again, it's an image that's acquired, and you would just go, all the lab information is stored under the H drive, under lab resources, and then in there you've got resources for the different labs, right? So the final, lab 1, and so on, lab 3, 4, including the USB, right, for lab 2. Lab 3, 4, you just have the VMEM and the hard drive. So this is the one we're interested in, and you would just add that. I don't need to do that because I've already added it. And when you add it, it's going to, FTK is going to index it, and that takes quite a bit of time, but you can actually start working with it before it's been finished indexing. So here's the first partition, and this root drive here, this is the actual drive we're looking for. So just like, so with Ncase and FTK, either one, they have this, this, in addition to the normal plus and minus that opens and closes a tree, like in Windows Explorer, they have this additional button there. And what that does is, instead of looking, without doing that, if I click on root, then I'm just looking at the things that are in the root of the hard drive, or in the, so it'd be the things that you would see if you listed what's in on your C drive, right? Or if I go to inet pub, I would see everything in the inet pub drive. Same thing, Windows, I'd see everything that's in the Windows drive, or in the Windows directory. When you hit this, now you're looking at literally everything on the entire disk all at once. So it shows you not just contents of one folder, it shows you all of them pushed together. And what's beautiful about that, and it is beautiful, let me tell you, is that you can sort, and it will show you everything on the entire drive in the order which you sort by. So for instance, I'm going to sort by created date. And I can look at the entire drive, everything when it was created. So the last things created on this drive were created on December 16th, 2013. Where's that date familiar from? That's the date we were seeing in the Wireshark data, in the PCAP data, right? And then the times here are 5 a.m., which is not at all the times we were seeing in either of our settings. So this must be from yet another time zone or something, but the date matches what we were seeing in Wireshark. So hopefully we can come up with some kind of correlation for the dates, because what I'm looking for is I'm looking for files that were created near the end of this machine, basically shortly before this image was taken, right? Because we're looking at the last ones to be created, which are going to be files that were created just before the machine was shut off and the image was taken. So up here we'll see the actual file contents. Right, we can see it in hex. This is kind of the native way to look at the files. So this file has, has all the bytes are just 0, so there's nothing really much to it. These are all zeros too. So that's kind of how to use FTK. So what I want to look at is, I'm just going to go through here and try to find the last files that were changed in here. Here's one in Documents and Settings, All Users, App Data. It's a manifest. So this is a VMware file of some type. So I'm not sure if this is going to be relevant for us, so let's just keep going up. So long story short here, I was looking from the most recent files up, and I didn't really end up finding anything useful that way. So I ended up having to try a different tactic. I'm not finding what I want to find this way, so I'm going to switch it up a little bit. Let's look alphabetically. So again, now we're searching through the entire hard drive alphabetically, looking at every file on the entire drive all together. And we're looking for TAH, Tango. Boom! There's tango.exe. All right, so tango.exe was written to System32, and that's where it's running out of. Interesting. And it was written on, apparently, October 30th, 2009, which, if I'm not mistaken, I have to do this exit full screen thing here, which, if I'm not mistaken, is what volatility was saying was that's the date volatility had. So there's something really weird about the dates on this hard drive with FTK. So here's tango.exe, and here is. So here I am fumbling around a little bit with FTK. Like I said, I don't use FTK all that often. I usually use ncase, which wouldn't read the file for this lab properly, so had to use FTK. So it took me a while to figure out how to find the hash, and I'm going to speed this up for you a little bit, just get to what really worked. So the great thing about FTK, or I'm sorry, about the lab, is that it gives us access to our own custom documents. So for lab 4, I can export. So what I'm doing here is exporting the file list info. So that's, I'm calling that file list Tango. And then I can go to that same documents folder here. So it gives us this wonderful. And the great thing is you can access this. Someone was asking earlier this semester, like, well, how do I get documents out of the lab? And the way you do that is you put them in here, because you can access this same documents folder from your normal student workstation. So this will give us all the same information that we could see in that file listing. And so here are the hashes. So this is the hash I want. This is the MD5 hash. So I can copy that. Okay, so normally you would want to hide this toolbar. That way you can get up here. So this window is my remote desktop connection to the lab, and so on my student workstation I can go to VirusTotal and search up. Ooh, what is this? Interesting. So VirusTotal is quite familiar with this particular tango.exe. It's funny because a lot of people in their write-ups said tango.exe is a, I'm not sure why everyone thought this, but they said, oh, it's a program for making what am I talking about? Oh, it's a program for making like video conference calls or doing conferencing, and that would be weird to have on a server. It is weird to have a conferencing utility on a server, but so I'm guessing people must have just searched by name and figured, oh, okay, this must be this must be this thing because it has the name, right? Right, Tango is this free video communications service. And so that's what they were seeing, was by searching up the name, saying, oh, that's what tango.exe is. Well, remember, file names are just names. I mean, someone can name a file anything they want. And so, bad guys name malware with all kinds of names that are not its real name, I mean, so don't ever rely at all. Don't rely at all on the names that you see on file names and search the file name and think, well, that's what this thing is. The hash, hopefully, I mean, I'm sure you guys have and learn. If you don't understand hashes, just real briefly what a hash is. A hash is a unique value that is an identifier, like a fingerprint, essentially, of a file or any collection of information, right? Even like an entire hard drive would have a hash. So you can hash the entire hard drive when you take a drive image, and then that proves that you can later prove in court that the drive hasn't changed because the hash hasn't changed. So the hash, if you take any arbitrary amount of data and hash it, it should always be the same, as long as the data hasn't changed. So by hashing a file and then looking up that hash in VirusTotal, we can see what that file actually is, right? So interestingly, VirusTotal knows this thing as tango.exe as well. So VirusTotal gives us all kinds of great information about it, right? It says all these different antivirus tools detect this as malware, right? And so we see the different names. It's some kind of backdoor, SWRORT. We see that in a lot of them. So I like to look at what Microsoft calls something, because Microsoft, I find, has the best write-ups about malware of almost anybody. Okay, so Super Anti-Spyware says this is Poison Ivy. Now, Poison Ivy is a pretty common backdoor, so maybe that's what it is. But let's see what this thing is identified as. SWRORT. It comes up first in Microsoft's site. So let's see what Microsoft usually has the best explanations of what those names really mean. Like, what is this thing? So they'll tell us, oh, this is what it has, all these other names that other companies call it. Technical information about it. It's a file that tries to connect to a remote server, which we know is what tango.exe was doing. Once connected, an attacker can perform malicious routines such as downloading other files, which is what we see them doing, right? We see them downloading Meterpreter using this thing. We've seen it connect to the following. Sometimes it connects on port 443, right? So that description is very much what we're seeing. So it doesn't really give us sort of a common name for it, just SWRORT. But we know at least that it's that, right? So so we've identified it, right? We've said, okay, that's what this is. So usually in my report, so when I write a report, I'll usually put a link to this. I will put this link to VirusTotal and say, we found the file, trojan.exe. It was at this path. And this is what it really is. Here's the link to VirusTotal, right? So maybe create a table with all the malicious files that you found, where they were on the disk, what they really were. So you want to create, your report should have, one thing about the reports that I received is most of them were like all written out as paragraphs, which is great, but I got to tell you, forensic reports have lots of lists and tables in them. So think lists and tables and timelines and that kind of data, not a bunch of descriptive paragraph type writing. Good forensic reports are very table and very data heavy. All right, so that's tango.exe. So now that we found that malicious file and we have this time, right? And interestingly, 1:55 p.m. is not any of the times that we had on our other stuff. So what I'm going to do is sort by time again, and then go to that time, where tango.exe was, right? So it was 10/30/2009. Okay, oop, there it was. All right, so there's tango.exe. So you can see what I'm doing here basically is I'm looking at other files that were created around that same time. Well, interesting. Here's svchost.exe. Well, this svchost.exe is not located where svchost.exe ought to be located. It's located in the system profiles local settings temp folder. This is not servicehost.exe. WCE, I have a feeling I know what WCE is. They're calling it WCE1. I have a feeling I know what that is. That's a very common hacking tool, so we'll see if that's what I think it is. So you can see why I sorted by time, right? Like I said, timelining is very important. So I'm also going to grab, so you can see the, all right, so I sorted by time. I'm going to grab this file as well. So this is a web log. It's a web server log. This is probably from before the attack, though, because you can see the time, right? It's from, we sorted by time, and it's from before the attack. So this is where the web logs are stored. And we're going to want to go there and grab the other logs as well. So let's look real quick and see what else. Okay, so look, this is interesting. So someone was looking at the web logs. So this link file here is in the administrators folder at recent things. So someone was looking at the web log before the incident happened. That .lnk file was created when someone looked at it, and it creates a link in your recent documents. So 10 minutes before our incident, and this is actually, I think it's during the incident time frame, someone was looking at the web log. So let's grab that. We don't really need the link file though. So what else is there here that would be interesting? Home.htm, maybe, if it's been modified. I mean, why would that have been just created or modified? So someone modified it right after the incident. So that's unusual. So I'm going to grab that home.htm as well and see what the deal is with that. But so you can see right around the time of that when this file was written, that these other two files were written too. So svchost.exe, well, that's probably that weird SVC host we saw running. It wasn't a real SVC host at all. It's not even the real SVC host executable. It's just a piece of malware named that. So you can see where what I was saying earlier, right? You never trust based on a file name. You never go based on a name of a file to assume what it really is, because it's often not. So I'm going to take all these that I've checked off, and I'm going to export that file list info the same way I did with the other one. And I'm just going to call this one file list because it actually is a list. And then we'll go back here. Did I close that? Why did I close that? All right, so go to my documents, open up a file list, and so I have this nice list here. And these are the hashes, so we can grab the hash for, well, we don't need a hash of a log file, but WCE and service host are this one is WCE. So let's see what VirusTotal has to say about that. WCE. It's a hacking tool. It is probably exactly what I thought it was, which is WCE1 is actually just plain WCE, which is, see how it says Windows WinCred. WCE is also sometimes known as Wisdom Eyes here. Baidu is a Chinese company, and their AV has the coolest names for things sometimes. You can see that good old CrowdStrike Falcon says this is 60% malicious. And there's a reason it's actually correct, because WCE is not a Trojan. It's a credential hacking tool, right? So you can see McAfee actually gets it the best name for it, which is just says, look, it's WCE. So WCE stands for Windows Credential Editor. That's the name of this file we're looking at. WinCred. And so looking what these various things called. But so let's look up in Microsoft's. So what happens here is I'm looking for Microsoft's page that describes this piece of malware, but it was disappointingly bad. So in the end, I ended up just kind of cheating and going directly to what I already knew was the homepage of the company that actually makes this WCE tool. It's actually a commercial security tool. To show you all what WCE is. Windows Credential Editor. So Windows Credential Editor is actually a tool which is put out by a company called Amplia Research. So it is a hacking tool, but it's actually a security tool, because it allows you to add, change, list, or delete credentials, and also login tickets. It allows you to pull hashes out of memory. So it allows you to do all kinds of great things, dumping out clear text passwords that are stored in memory by users. It's a great security tool, also a great hacking tool. There's another tool that's very similar to WCE that's actually more widely used by the bad guys and by hackers. It's called Mimikatz. Let me spell that for you. Mimikatz is a more of a hacker tool than WCE, but both of them can be used by hackers. Both of them are used by both good guys and by bad guys. They do both very similar things, but basically they're tools for grabbing credentials off of machines. Is pretty much what they are. So that's what we were dealing with here in this WCE1 file. And then let's look at svchost.exe, which I don't think really is svchost.exe. Maybe it is. It wouldn't be unheard of for bad guys to literally write a Windows file like WCE, or I'm sorry, not WCE, like svchost, and then use it for nefarious purposes on the machine. But I don't see why they would do that, because servicehost.exe would already be on the machine, and running it out of application data would just be very suspicious. Okay, so here we go. Tango.exe. So notice svchost.exe, I should have noticed the hash is the same. Right, so if we look at the two hashes, they're the same. 13b6, 13b6. I probably should have looked at that. So svchost.exe and tango.exe are really the same thing. And that's not really surprising, because if you remember correctly, those two are both the processes that both reached out to the attacker machine on port 443. So they're basically that same program, and it's not surprising because they're doing the same thing. So those are the malicious files that we see on this host. So like I said, this is the weblog. So let's look at this home.htm. There we go. Mess with the best, die like the rest, arf arf, hacked by Overlord. Right, so this is what has been written as home.htm, which is the home page of this web server. So this is a pretty common thing that hackers will do. There's a whole subculture of hackers that are what we call website defacers that deface websites, and they have cool hacker names, and they like to spell things with goofy letters and brag about the fact that they've hacked into machines. And there are even whole websites that are basically serve as scoreboards where they keep track of which hacker crew has hacked the most web servers. And so it's pretty common to see them do this kind of thing, defacing a web server after they've hacked it. So remember I mentioned this is a weblog, but this was a weblog that actually closed out before the time of our attack. So what I'm going to do is I'm going to do another thing we can do with FTK, which is I'm going to actually export this entire file. And export all the checked files. And we're going to put them in. I'm kind of worried that if I put it in my documents folder that the student machine will freak out because I've got malware there. Let's see. It might. It might freak out at the WCE and the Tango. Like I said, WCE is not, in a way, is not technically malware. So like when we saw the one that CrowdStrike labeled it 60% confidence that it was malware, because it's not always malware. It's used by the good guys too. It's used by people to actually solve, to do maintenance and solve problems on computers. It's not just malware. So FTK is going to allow us to export these files and save them off onto another drive, or onto the drive. So if you find something in the image that you're interested in, you can save off and actually look at the actual file itself. And we'll often do this when we want to do like reverse engineering of malware, or try to figure out really get more close look at what specific piece of malware is. This is taking a long time. I don't know why. It really shouldn't take so long. There we go. That's why. Because look at that. I love it. PUA, right? Oh. So the Sophos antivirus didn't like the fact that we copied these files out. I kind of thought it might not. Okay, but this log is what I was really interested in exporting, because here we can see all of the hits from the attacking machine, right? So this is this is information about the server. So this is the server IP, and then so this is much easier than looking at it in Wireshark. And so people were looking at it and saying, "Oh, this guy's trying to guess passwords." He wasn't really trying to guess passwords. This was more of a web vulnerability scan, is what he was. He was really running some kind of web vulnerability scanner, because first it was trying to do. These are all basically SQL injection attempts here, and then it was trying to call a whole bunch of commonly vulnerable websites like PHP MyAdmin and all these other commonly, like there were a bunch of people on their reports who said Polar Bear CMS was what was exploited, but you'll notice that when he tried to hit Polar Bear CMS, the result was, why is this not working? But when he tried to hit Polar Bear CMS, the result was a 404, which means Polar Bear CMS doesn't even exist on this machine. So there is no vulnerable Polar Bear CMS website on here at all. So all these things it was trying to exploit all got 404 errors. 404 error, 404 errors. These are all a bunch of errors, right? And then so all this advanced data factory stuff, this is all 404s, right? All this Microsoft, script tool, new DSN, 404, 404, 404. So all these attempts that were made before the successful attack, this is all the various web attack stuff. And it's funny because when I first saw this, I had said, oh, it looks like a web shell thing. I think I was wrong about that, and I have to apologize. Because that is not, that's what it looked like was happening, because he's definitely posting stuff that looked like he was posting to a web shell, but actually he was just trying to find a vulnerability on the web server and failing to find one. He never did find a vulnerability on the web server at all. He instead attacked it with that SMB vulnerability we were talking about. So, and that weblog, I guess, had everything I needed in it. It didn't. We could look and see, but I mean, we can see the modified. We can see these are all the files that were modified after the attacker got on. I think that's really all we're super interested in. Here's this other apocalypse. I wonder what that is. That doesn't sound good. I mean, apocalypse is kind of a ominous sounding name for an executable. And it's got apocalypse server logs. Anytime you see something spelled with a 0 instead of an O, you know it's probably something bad. It's to stereotype something, but here's the apocalypse server logs. So let's see what this apocalypse thing is. I'm gonna export the file list info just for the one that's highlighted, not the ones that are checked. So this is apocalypse, and let's pop back out here. And here's apocalypse 32. So here's its, dang it. All right, so here's its hash. Open up a new virus. Actually, I'm going to use the same virus total window because we already know that this was the same as that other one. Ooh, apocalypse is a winner. It's detected by almost all the antivirus engines that VirusTotal has, and so here you go. So you can see where I was going with what would be in a report, right? Or it would be great if a report had a list of the malware that was found, right? We found this malware, this malware, this malware, this malware. If it had a list of them, it said, I found this file, it was in this folder, this is the hash. Here's a link to what VirusTotal says about it, right? And you have a table, right, or a list that has all that information listed, right? So that's why I'm saying the reports should have lists. So Leipzigup. Mahato. All right. Technical details. Okay, it's a Trojan, gets downloaded, creates these server logs, adds the following registry entry to enable its automatic execution at every startup, right? So it adds a Windows run key. So we're going to want to look in the registry and see if this key was added to the registry to get it to run every time. Where would we find that information? We could find it in volatility. We could find it on the disk. We could find it in either of those places. All right, it says it drops these other files, htm.htm. Not sure what htm.htm is. And when we found Apocalypse, yep, it's in the Windows directory. So there we go. So let's keep going down and see if they added any other goofy things to our system here. All right, so I'm not finding anything else. It looks like it belongs to them. So I think Apocalypse is probably the last piece of it. So I skipped over some of the stuff we could have done in volatility. I'll make another video about that if I have time. But people were clamoring to see how things worked in FTK. So it's difficult because the times didn't really sync up. So if we look at this file listing, we'll see that the times. Okay, so the times were, it was October 30th at between 1 and 2 p.m. Right? And it's very difficult when you're running a Mac that then wants to pop up its own thing too. There we go. Okay, so in volatility, so 1 o'clock, right, we said it was between 1 and 2 o'clock. So 1 o'clock is 1300, right, which is 4 hours earlier than this, which means that the times we're seeing in FTK means that the times we're seeing in FTK, there we go, are, it looks like 4 hours earlier, whereas the other one, yeah, so this difference is just the difference between daylight savings time. Where is it? There we go. Yeah, you can see why this annoys people at times. It's not always the fastest. Okay, where's my, come on, show me my text documents. There we go. All right, so this was 1:55 p.m. Yeah, so that's 13 so that'd be 1,300 hours, right? Because these are in 24-hour time. So that'd be 1,300 hours. And we can see that was, so it's 4 hours earlier, which would be the appropriate time adjustment, like I said, for East Coast time in the summer, or for another time zone further east would be maybe like Brazil or something. So who knows? We don't know where this computer was located. It's not information that we were given, but you can see where the time adjustment is. So I'm not sure why the Wireshark times are like years later. That doesn't really make sense. Not sure what's going on with that. Maybe someone replayed the attack and captured it somehow differently. That's kind of annoying. It's a little bit of an irregularity, but you can see that if you kind of if you're persistent about comparing the times, that you can figure out what the offsets are. And the offset in this case, the offset time was pretty far in the, and it was not even it was the date offset is way off in Wireshark, whereas in FTK, it's the dates are actually the same as in volatility. It's just 4 hours earlier because we're looking at local time, not UTC. I suspect that's why. With 4 hours, I'm used to seeing that all the time because I'm looking at computers here on the East Coast of the U.S. and its daylight savings time more than half the year nowadays. So it's usually 4 hours less. So this video has gotten really long, and hopefully that won't give me trouble, because sometimes the computer gives me trouble with really long videos. So I'm going to end it here. And if I have time, I'll do a little bit more volatility stuff later on. But hopefully that will help folks to understand the kind of things you want to do in FTK. That's just the very basic stuff in FTK, to find malicious files when you don't even know. All you really know is like the name of one of them, or a time or a date. We didn't know the times or dates because of the way the times were offset.